Good morning, everyone. My name is Jafar Sadiq Ali, working as a professor in the Department of Electrical Construction Engineering of Sri Muthukumar Institute of Technology, Chennai. I'm handling a subject IoT concept and applications. And this is the syllabus. Last class we have seen in the unit 1 of introduction of IoT. We have completed the first part, evolution of IoT. And now in this class we are going to see the second topic, the enabling technologies, IoT enabling technologies. Now we move on to that. There are five enabling technologies for enabling the IoT are available. First one is wireless sensor network. Second one is cloud computing. Third one is big data analytics. Fourth one is communication protocols. The last one is embedded systems. So these are the five different type of technologies using by which only we can able to make the IoT deployment in any systems. The first one we will see what is wireless sensor network. Sensors basically we know what is sensor. It's a accept the physical parameter as input and generate a electrical signal as output from the real world to digital world. That's the main purpose of the sensors. So what do you mean by wireless sensors? So all these sensors, be it temperature sensor or fire sensor or gas leak sensor or humidity sensor, soil moisture sensor, all sensors need not be connected through wired. Everything should be in a network wherein all are connected through wireless. That's what wireless sensor network. See that? See the figure right from the remote user left hand side, cell phone user. All these users are connected to the internet, and these users through the internet they have a gateway node. In this gateway node only they are able to access a particular wireless sensors network through authenticated privileges only. They can able to enter into that particular area, and all the nodes, see that near the trees there will be a one node, brown color wireless is a node will be there, and another one also is there which are connected to each other. The four nodes are shown, each are connected, interconnected, and all are connected to the one gateway node, and through gateway node only it goes to the internet, and through internet only it goes to the server database or the web user database or cell phone database users also. So distributed devices with sensors used to monitor the environmental and physical conditions. It's a network formed by large number of sensor nodes to detect light, heat, pressure, water, etc., etc., used to monitor all the environmental and the physical conditions. Each node has several sensors attached to it. Each node can also act as a router, and it has a various role play coordinator also is there, which collects the data from all the nodes. And from the coordinator node is responsible for sending through the gateway to the internet. So this is the one such type of the network which enables the IoT deployment possible. This is the most important one, wireless sensor network. So we go back to this. So first one, wireless sensor network we have seen, and second thing is cloud computing. What is okay? If you're going to computing, we can just go through this applications, WSN, this and all. You can go through it in everywhere. It's been applied. Cloud computing means now you want it's a cloud-based computing. All the computings are not done in the client side. Everything has been put it into a one common platform from different type of users, different type of nodes. All the data are sensed by the sensor nodes. Sensor nodes sending the data to the server, and there only the computing takes place. In this common repository, if computing takes place means one change, only one place the change will be taken place, and everywhere it is being reflected. That is the whole beauty of this cloud computing. So cloud computing is the delivery of the computing services, including servers, storage, databases, networking, software, and also analytics part also, and also intelligence to make informed decisions also, only in the internet, to offer what for, to offer very fast innovations based results, flexible resources, and economic of scale. If you want to improve your scalability with the minimum low cost, then this will drastically will help you. And there are some types of available which we'll see in the later classes. Just to go through the only that name of the types of the clouding computing services is infrastructure as a service. It's called IaaS, platform as a service, and software as a service. So what do you mean by this means? Infrastructure means you don't have to purchase any laptop. You don't have to purchase any hard disk. Everything is available on the cloud itself. You can pay and use it for the particular amount of time. Then you can withdraw your account. That's what infrastructure as a service. And likewise, platforms as a service, and also software as a service means no software is to be purchased or licensed for purchase. We can just subscribe for the particular software, and you can use it for the particular time period. Then you can come out of that service. So then later on you can subscribe for another software, and you can use it. So it's a very versatile uh, service has been introduced by in the cloud computing. That's what the benefits of cloud computing says. It does not require you to maintain. You have to don't have to maintain or manage it. Everything is done by the cloud itself. Say for Amazon Web Services is there, so they will take a Microsoft Azure Web Services is there. They will take care of it. You just go and pay the rent and use it and just come back. And number two is effectively the infinite size. The huge amount of data can be stored. No need to worry about the running out of capacity also, memory also. And you can access any cloud-based applications and services from anywhere from the world. So that is the whole beauty of this cloud computing. So this is the second part. So we will go to the third one is what is big data analytics. So see what is big data analytics. Nowadays we are using social media, and we are getting from Facebook, Instagram, and WhatsApp messages, and lots of other social media apps also is there. Everything is data. So all this data volume is very huge, and different type of data also is available. Raw data is available. Everything is so clumsy. So from this data, if you want to understand a particular pattern of a particular user, how what he is searching for, then you cannot do it manually. So that there's a technique called big data analytics is available, which will just do the collection of all the data, irrespective of a huge volume or velocity or in any type of variety also is there. It's very easy for it to analyze the data and give you a proper usable format data for the customer. So big data analytics involves the data cleaning process, data wrangling process, data processing, as well as data visualization processes. So all these stages comes under big data analytics, which we will see later in the subsequent classes. So big data is give you useful information from the raw data. And the fourth one is what we discuss is communication protocols. So we'll move on to communication protocols. So communication protocols is the backbone of IoT systems. From one layer to another layer, if you want to send the data, you need to follow some rules and regulations, terms and conditions. So if you want to take a policy means there will be lots of terms and conditions will be there. Likewise, all over the world, there are billions of sensors are available. Everybody is start using it means everybody has to follow certain rules and regulations. Then only the system will be stable and safety. So for which we there some protocols has been defined by the some community forum available in the Europe countries, and we are going to follow those protocols. So that's what the main thing in the IoT systems, backbone of IoT systems. It's allow devices to exchange data over networks. So particular type of sensors which is used in the say in the home, there will be set of sensors will be there. In the automobile industry, automobile car, there will be some type of sensors available. If you go to the market area, there will be a surveillance camera will be there, for which there is some type of sensors will be needed. If you go to industry, there will be some type of sensors will be needed to monitor. And if you go to some power plant, some oil and gas producing, petroleum gas producing companies means very highly critical kind of thing. There are a lot, some kind of sensors need to be uh, imparted. So all these sectors, they have to follow certain type of rules and regulations, and that's what the protocol need to frame it, and they have to follow it. Define data exchange formats, and also there are some functions which need to be built-in functions which need to be followed for data packaging, transferring, and controlling, and how we can restore the lost packets of data. All those things, have been defined in the commercial protocols. So without which we cannot able to just like that use the protocols and go for it. It's not possible. We have to follow certain things. And the last one is out of the five, the last one is embedded systems. What is? We'll go to the embedded systems. Yes, embedded system is nothing but a microcontroller-based, software-driven, reliable, real-time control system designed to perform a specific task. What is embedded systems? See the example: industry robot. It uses a GPS receiver or digital camera, DVD players, microwave oven, photocopiers, set-top boxes, gaming consoles, all wireless routers. These are some of the examples, and we have in home we have washing machines. So everything is programmed in a small chip, and the or SD card, and the SD card is inserted inside this device itself. This is and program has been done inside the SD card itself. This enable that particular device as more intelligent and do some specific task based on the parameter that receive. It is going to do operation on its own. That's called as a embedded systems. It's a combination of hardware as well as software used to perform special tasks. It includes microcontroller as well as microprocessor memory area, networking area, input output devices, and finally the storage devices also. It's all combination of all this is comprises of embedded systems. So this we will need to be discussed later on in depth. And with this, we have concluded our session. Thank you.